So the second page of notes today has two families of functions that unfortunately you weren't able to learn as much about as we would have liked for you to, losing the days that we have due to e-learning and everything that's been happening. You're just going to get an overview of what these functions look like, what do their equations look like, what do their graphs look like, and then you'll really get into more of the ins and outs of these families of functions in Algebra 2. So absolute value, we did talk about absolute value earlier in the year, and we solved absolute value equations. Well, the absolute value family of functions have the absolute value symbol in them, and their generic equation, sorry, I moved the camera, is a absolute value x minus h plus k. And I realize that that looks weird, and that's okay. The key is you can tell it's an absolute value equation if it has the absolute value symbol in it. It's a pretty good giveaway. You're not going to really learn a whole lot about what A, H, and K mean until you get into Algebra 2. I'm going to tell you what they are, but I'm not going to expect you to be able to graph these for me at this point. The A on the outside is going to tell me how steep my graph is. It's going to vertically, which means up and down, stretch or compress that graph. So the bigger the number out front, the steeper the graph. If A is a fraction, it's really fat and stubby. This H inside the absolute value with the X tells me whether my graph gets moved left or right. So if there's an X minus 3 in here, it's going to be shifted right 3 units. If there's an X plus 5 in there, it's going to get shifted to the left 5 units. Again, I'm not expecting you to graph this, I'm just telling you what they represent. And then this plus k out here at the end, that tells me whether my graph gets moved up or down. Because for all of these functions, we have a parent graph. And the parent graph is the most basic form of any function, and then every other member of the family is just some transformation of that. You'll spend a lot of time in Algebra 2 and Pre-Cal doing those things, so something to look forward to. But this K just tells me whether I pick it up and move it left or right, or I'm sorry, up or down. And the graphs, well, they look like V's. So the graph of the absolute value function is a V. It might be really steep and close together. It can be really fat and squatty. This A out front determines whether it's steep or fat. And it also could be flipped upside down. That happens when this A is negative. But it could be a V that's flipped upside down. And that happens sometimes. So the key when you're doing the problems that we're wanting you to do right now is just to look and see, is it a right side up V or an upside down V? Parabolas are U's. Absolute value is a V. So how can we tell this from a table? Well, this is going to be kind of like when we talked about parabolas on the previous page, but you'll notice something here. As we're looking at our y values, we subtract 1, add 1, add 1. Well, our signs changed, but our values stayed the same. When we did the parabola, we went -3, -1, +1, +3. So the signs and the values changed. Here, only the signs change. If the value remains constant, but the signs change from negative to positive or positive to negative, that's how we can tell it's an absolute value function. So we're going to be looking at these y values, but what we realize is that as we're changing signs, our value remains the same. And that's how we know it's absolute value from a table.